Variables. Variables are something that I'm to stress in our physics class. They're going to vary, right? You get something like variety, various. There are things that can change. Pretty straightforward, right? So in our science class, a variable is going to be could be an object, an event, an idea, a feeling using the five senses, period of time, or any other category that you're just trying to measure. Okay, variables can change and they are measurable. So in any experiment, we are looking at basically three variables: an independent variable, a dependent variable, and some controlled variables, okay? So our independent variable differs from our dependent variable, and our controlled variables are the things that stay the same. What's the definition of an independent variable? This is what is varied during the experiment. It is what the investigator thinks will affect the dependent variable. It's what I can change. Now, the job of the independent variable is going to identify the cause, okay? This is going to be the cause in your cause and effect relationship. If I change the independent variable, then some effect on my experiment should occur. On a graph, the independent variable is on the x-axis. This is very, very important. A dependent variable is going to be what is measured. It's what the investigator thinks will be affected during the experiment. This is going to be what is affected. So its job has to depend on what other factors, okay, do to it. This you cannot change. The dependent variable only changes because of something that happens with the independent variable. And when you're looking at a graph, the dependent variable is always on the y-axis. Controlled variables, we're going to say these are variables that never change, meaning they are held constant. If you were doing an experiment where you were studying the effects of fertilizer on a plant, you're going to have to use the same type of plant. You're going to have to use the same soil. You're going to have to use the same water, the same light, the same temperature, because the only one thing you want to experiment on would be the amount of fertilizer. So the job then of this control variable is to eliminate the possibility of other factors affecting the results. We never change the controlled variables, and you only want to test one variable at a time, so you keep your controls the same all the time. Right? So these do not get graphed, right? They don't get tested, so they don't get graphed. This is different than, if you had a control group and an experimental group where you were comparing your groups in say, a bar graph. All right, so let's try to make an easy way to remember this. The independent variable causes a change in the dependent variable, and it isn't possible that the dependent variable could cause a change in the independent variable. Let's do some examples here. Controlled experiments. These are experiments where a control group is compared to an experimental group. Let's say you're growing some plants, and one plant you just have in regular light, and in the other plant you have a special growing light. The special growing light would be the experimental group. So controls, factors that stay the same or constant in an experiment. So for example, temperature, humidity, amount of a substance. If we're growing plants, the controls are going to be the temperature, humidity, amount of soil, number of seeds, amount of water. It's the group in an experiment that is not being tested. And since variables are factors that change in an experiment, we want to have one variable to test. An experimental group is an experiment that is being tested. This is the group with the variable. So the independent variable is the one factor in the experiment that you or I want to test. So I like to think of I independent. This is what you're changing in the experiment. Dependent variable is the factor that's affected by the independent variable. So if we were testing plant growth, we could measure the results of the dependent variable. We could measure their growth. We can see how many centimeters they grow. Okay, and we could base that, or we could test that off of how much fertilizer one gets. Or let's say one gets a certain brand versus another brand, or one brand versus no brand. Okay, so let's do an example with Bob. Bob has mosquito spray. This summer, the bugs were biting quite a lot. So Bob wanted to know if his new formula for mosquito spray would repel more mosquitoes than the original formula. That's a typo, it should say than, not then. Bob thinks that the new formula will repel more mosquitoes than the old formula. Okay, so what should Bob do in this experiment? Well, here's how he set it up. He has two groups of campers. They're gonna sleep under the stars for one night. Group 1 uses the old formula of mosquito spray, and group 2 uses the new formula. The next morning, Bob counted the number of mosquito bites. It's measurable, right? On each person that he had in two groups. In our control group, group 1, you have the old formula. In our experimental group 2, you have the independent variable of the new formula. And our dependent variable is how many bites. So that you can count. All right, so this kind of leads us into like how to analyze the data. We're going to be using mathematics. It is literally the language, the syntax, the grammar of science. So when the ideas of science are expressed in mathematical terms, they're unambiguous. They take on a direct meaning. They have equations and formulas of science to provide compact expressions of these relationships. So one of the first equations you're going to do is, speed is distance over time. Okay, so the distance divided by the time gives you the speed. That's the relationship right there. So it takes the phenomena and it puts it into numbers. So the methods of mathematics and experimentation have led to enormous success in science. So yeah, there's going to be a lot of math, but you're going to be okay. I'm going to walk you through every single equation we take in class. We're going to give you equation sheet to use on your tests and quizzes. So it's nothing to get overwhelmed by, but think of equation as a way of seeing the phenomenon. We see the phenomenon in words, we see it in numbers, we can see it in pictures, and we can see it in experiments. But one thing I want you to know about this math being the language of science, when scientific findings in nature are expressed mathematically, they are easier to verify or to disprove by experiment. This is where our data becomes very important, okay? You need the numbers, you need the math to show actual differences or changes. And here are three of the most common units we're going to use. We're going to use SI units in the physics class. And when we use time, we're going to use seconds. Position is generally going to be meters, and mass is going to be measured in kilograms. So one change you might notice would be this one. Let's say in chemistry class, you were dealing with small amounts of matter. You probably dealt with grams. All of our, or most of our physics equations have kilograms in them. So we're going to be using kilograms an awful lot. And then let's say you have a distance or displacement, any position that's measured. If it's in kilometers, we'll have to convert it to meters. And time, we're going to want to keep in seconds. Okay, so we're going to use seconds, meters, and kilograms the most. How do I want you to organize it? Okay, before you organize data into graphs, you will be given or creating data tables. A data table is just a place to put information in an organized fashion. And here's some criteria for that. You want to have a title at the top. Every piece of data or variable has to have a title, and you'll see that in columns. Each variable must have the unit. You want to put the parentheses. So if you're measuring something in meters, it'd be parentheses M. And the data table is being closed. It's, closed off. You guys have seen this. I'll show you a picture of it in the next slide. And we're going to use straight lines. Okay. So if you don't get a data table that's typed out for you or boxes given to you, you'll have to just create one nice and neat with straight lines like this. Take a look at this example. Columns go up and down. The columns get a heading. So for example, they were measuring height in centimeters. The unit was in parentheses. Here are the trials. They get headings. And the entire table has a heading above here where it says distance the ball traveled. Okay, so you leave room for multiple columns for multiple trials, and a lot of times we'll be doing averages. So it allows for repetition and averaging. Pretty straightforward stuff. All right, 3 types of graph that I want you to recognize in your science class. Number one thing I want us to be using is a line graph. The line graph consisting of at least one line, generally used to show trends or patterns. I believe a line graph is the best way to show relationships between 2 variables. A bar graph is another graph that we could use, and it consists of bars generally showing going vertically, used to show comparisons between 2 items. It could be more than 2 items. So anytime you want to compare items, you want to use a bar graph. You use a pie chart or a circle graph. This is the type of graph that can be divided into sections, and it shows percentages. It can show a portion. All right, and that is it.